refraction, we're going from deep water to shallow water. So the first thing you need to know is that water waves travel faster in deep water and slower in shallow water. And then we're not going to do this part of the question, but I'm just going to use this space to write fast. Okay, so faster, slower. So if waves are going faster, they bend away from the normal. If they go in slower, they bend towards the normal. So we know that when the wave goes from deep to shallow water, it's going to go slower. So it's going to refract towards the normal line. So that's the first thing we figured out, okay? So it's going to be slower, it's going to refract towards the normal line. So now we can start to think about the diagram. So the first thing that I would recommend with this diagram, and it's a little bit awkward, this diagram, the way the WJEC have put it together, is to extend the ray so that it actually reaches the boundary here between deep and shallow water. Obviously you should use a pencil for this. I'm going to use a green pen so that hopefully you can see it a bit better on the grey diagram. So I've just extended that ray now so that it's incident on the boundary. Now the next thing we need to think about is the normal line. If you remember, the normal line is at 90 degrees to the boundary. So you could use a protractor for this, or you can use a ruler and kind of cheat. And the way I'm going to do it is use the ruler. So I'm going to cheat with this. I'm going to make sure that my ruler, I'm going to take one of the centimetre lines here and line this line up with the boundary. And then I'm going to shift it up to where that ray hits the boundary. And because I've lined up the 14 centimetre mark with the boundary, I know that my ruler now is roughly at 90 degrees to the boundary. So I'm just going to draw my normal line down the page like that. Okay, there's my normal line. And I know that that is at roughly 90 degrees. Obviously, if you use a protractor, it'll probably be better. Now, the next thing is we're going to now need to draw the ray, or perhaps ray is the wrong word here because it's not actually a ray of light, but we're going to draw the path of the water wave now as it goes into the shallow water. Now we know that the water wave is going to bend towards the normal. So we need to make sure that this is our incident wave. We need to make sure that our refracted wave is going to be bending towards the normal. Now it doesn't really matter how far we bend it towards the normal, but we're going to bend it a significant amount towards the normal. So we just decide where we're going to draw it. It doesn't really matter where, as long as it's closer to the normal than the incoming ray. Okay. And then the final part, which is the most tricky part, is to draw the wave front. So you can see that these wave fronts are at 90 degrees to the sort of direction of the wave, to this line showing the direction of the wave. So the way we do this is, again, I'm going to use my ruler to cheat a little bit. I'm going to line up my ruler with one of the centimetre marks. So you can see that centimetre mark is in line with this line that shows the path or the direction of the water wave. And I'm going to make sure that my ruler now is adjacent to the end of one of these wave fronts, and then I'm going to continue this wave front along there. So I know now that my wave front is at 90 degrees to this line showing the direction of the wave, because I've lined up the 8 centimetre mark there with that line. Okay, and then I can do the next one, so I can continue to keep the 8 centimetre mark in line with this line showing the direction of the wave there, and then I can draw the second wave front like that. Okay, so we've got to make sure it's in contact with the original wave front, and then I can do a third one just about there. Okay, so I can just about sneak that one on there. So I've now got 3 wave fronts, and you'll notice they are roughly equally spaced. My diagram might not be perfect, but it's pretty good. And you'll also notice, because the waves have slowed down, the wavelength is much smaller than it was originally, and that's what we'd expect. So I can then continue to draw just maybe another couple of wave fronts just to finish it off. So I'm going to keep this centimetre line in line with that line showing the direction of the wave now. And I'm going to try and make sure that my wavefronts are equally spaced compared to what they were before. So there we go, there's another one. Okay, and I'm going to draw just one more then, trying to make sure that it's all lined up nicely. So this is in line with this to make sure that my ruler is at 90 degrees to the direction of the wave. And then I draw my final line in there, like that. Okay, and that should be fine. And you could continue to do that. You could draw more of these lines. So you could do another one if you wanted. I did say that was my final one, but I'll do another one. And the key thing is to make sure that they are all parallel to one another and equally spaced as much as you can. It doesn't have to be perfect, but just as much as possible. So there you go. So I've now got 1, 2, 3, 4, 5, 6 of these, and you've got to make sure that some of them are in contact with the original wavefronts. That'll be on the mark scheme there. Might be a good idea as well to put an arrow on this to show that that's the direction of the wave, and it might be a good idea to label this line here the normal line, just so that the examiner can see all of those details. The other key bit of information here is sometimes they ask you what's happened to the water wave as it's gone from deep to shallow water. So the first thing we can say is that it's slowed down, or the speed decreases. Okay, so the speed has decreased, it's slowed down. The second thing you can say is that the wavelength has decreased. And then the last thing you need to say is that the frequency remains the same. Okay, so it slows down, wavelength decreases, frequency stays the same. And if it was going in the opposite direction from shallow to deep water, it would speed up, the wavelength would increase, and the frequency would remain the same. The key thing is that the frequency always remains the same. Okay?